here synchronous motor construction. Here what are the objectives here? So objectives are constructional details of synchronous motor, construction of stator, construction of stator. Now here construction and types of rotors. Here, see, observe this one. Constructional details of synchronous motor. A three-phase synchronous generator is essentially composed of stator and rotor. See, observe this one. This here and figure, they given separately stator and rotor. It is a DC excitation. That is DC excitation DC, and the left side is a stator. It is covered with yoke, and the shaft is attached with the. So this is commutators. It means slip rings. The supply is used to the rotor. This rotor is the shown figure. A rotor is attached to the shaft. This is the stator and the rotor. Here cross sectional of a large turbo machine. So observe this one. So in the cross sectional views. Here we know the similar see, observe this one. Here this is the shaft. Shaft is so long. This is the long, and here the shaft attached to the bearings, and the shaft attached to the rotor winding. So here the rotor winding attached to this rotor and rotor. So the next one is stator, and that slots we have the stator winding. The rotor slots we have the rotor windings, and the housing means here the constructing of these yoke and difference, and cooling ducts for a ventilation cooling purpose, and for the connections, so there are connecting wires. This is the cross sectional of large turbo machine. Cross sectional of a large turbo machine. You see, this one, stator frame, stator slots, stator frame, stator slots. There's the winding is wounded in the slots. A man is wounding in the wind is wounding in the slots. See, observe this one. The stator slots, stator frame. How this will be appeared here in the figure. These are big size of stators. Big size of a machine. This is a big size of a machine. Here, stator. The stator is a stationary member of a rotating machine. In a stator frame, in a DC machine, the outer frame serves to carry the magnetic flux and holding stator field poles. Stop. In alternators, stator frame is means for only holding stator stampings and windings. So the difference between the stator in the DC machines and alternator, what they are saying. So in DC machines, outer frame serves to carry the magnetic flux and holding stator field poles. In alternator, stator frame is meant for only holding stamping and windings. That is the difference between the DC stator and the alternator of stator. So the extra work is in the DC machine is to carry the magnetic flux. This is a synchronous motor stator core, and stator core is laminated, and in that stator the slots are in that slots copper conductors are wounded. So here this is the terminal box, and the eye bolt, stator slots. So here the salient points of a stator frame. The stator is made of soft iron or silicon steel. Soft iron or silicon steel. So silicon steel is used to reduce as the hysteresis loss. Core is laminated to reduce the eddy current loss. Core is laminated to reduce the eddy current loss. So in three-phase winding wound in the stator slots with 120 degrees electrical part. So now the lamination are stamped out in complete rings or in segments. So here the laminations are insulated from each other. Laminations are insulated from each other. The laminations have space between them for allowing the cooling air to pass through. The slots for housing the armature conductors lies along the inner periphery of the core. Inner periphery of the core. This is the, see, observe this one, how the winding is. This is the rotor, how the rotor is constructing. Stator is constructing. This figure, observe these four figures. So some details of a generator stator. Here the, see, observe this one, metal frame, laminated iron core with slots, insulated copper bars placed in the slots to form the three-phase winding. To form the three-phase winding. See, observe this one. Stator of a large salient pole hydro generator. So space, insulated conductors, generator stator, rotor support with turbine and generator bearings. Generator bearings. So the rotor is the rotating member of the rotating machine. Types of rotors in synchronous motor: salient pole rotor, non-salient pole, cylindrical type rotor. Here, the salient pole rotor, see here, observe this one figure very damper windings. Damper windings are on the faces of the poles, shoe of the poles, and here laminated core, slip rings and brushes. Concentrated, very important. See here, so this one concentrated field winding. Concentrated field winding. Damper windings also. Here, this is the salient pole rotor. Salient pole rotor. It has a large number of projecting poles. It has a large number of projecting poles. Their cores bolted or dovetailed onto heavy magnetic wheels of cast iron or steel. Such machines have large diameters and a short axial length. Short axial length. The poles and pole shoes are laminated to minimize the heating due to eddy currents. Here, the poles and pole shoes are laminated to minimize the heating due to eddy currents. So, used for low and medium speed machines. This is the salient pole rotor, how it is rotating. Once again, observe this one. That is the stator. Rotor, it is rotating. Salient pole rotors. Here, turbine driven rotor, slip rings are showing. So, high speed is 1200 rpm. Salient pole rotor is low speed is 1200 rpm oracles cross section. Line of magnetic forces, that is a schematic, is showing. Yeah. So, here this is rotor of a 4-pole salient pole generator. So, DC excitation, slip rings, DC excitation and fans. DC excitation, winding, slip rings, and a rotor of a 4-pole salient pole generator with a smooth cylindrical rotor. Here a rotor block of a large generators. The rotor consists of a smooth solid forged steel cylindrical having a number of slots. So in this rotor places are non-salient and not projected out. Not projected out. It is used for steam turbine and driven generators. Such rotors are designed for 2-pole turbo generators. Here, the smooth cylindrical rotor block of a large generator. It is used for steam turbine driven generators. Such rotors are designed for 2-pole turbo generators. The rotor field winding is excited by a separate DC supply through slip ring. The rotor carries special winding called damper winding. The damper winding consists of a short-circuited copper bars embedded in the pole faces. So here damper winding helps to develop the starting torque and prevents the hunting. See here cylindrical rotor. So here the cylindrical rotor is given. So here it showing the starting at DC current terminals and the shaft steel retaining ring wedges. So large generator rotor completely assembled. The large hydro generator rotor with V of the vertical poles. This is the combination of stator and rotor. Combination of stator and rotor.